So let's see, what should we aim at first? Let's first find, and I'll do the calculations on the sideboard so that, I won't, we'll see how it works out. I'm not very sure. In other words, what's the Laplace transform of the function 1? Well, there's an even easier one. What's the Laplace transform of the function 0? Answer, 0. Very exciting. What's the Laplace transform of 1? Well, it doesn't turn out to be a constant. Now, you can do these calculations carefully, dotting all the i's, or pretty carefully, or not carefully at all, i.e. sloppily. I'll let you be sloppy after. Generally speaking, you can be sloppy unless the directions tell you to be less sloppy or to be careful, okay? So I'll do one carefully. Let's calculate the Laplace transform of 1. Carefully. Okay? In the beginning, you got nothing to use with the definition, so I have to calculate the integral from 0 to infinity of 1, that's the f of t, times e to the negative st, so I don't have to put in the 1, dt. All right, now, let me remind you, this is an improper integral. This is just about the first time in the course we've had an improper integral, but there are going to be a lot of them over the next couple of weeks. Nothing but. All right, it's an improper integral. That means we have to go back to the definition. If you want to be careful, you have to go back to the definition of improper integral. So it's the limit as r goes to infinity of what you get by integrating only up as far as r. That's a definite integral. That's a nice Riemann integral. So this is what I have to calculate. And then I have to take the limit as r goes to infinity. Now, how do I calculate that thing? Well, this integral is equal to, that's easy. It's just integrate. Remember that you're integrating with respect to t. So s is a parameter. It's like a constant, in other words. So it's e to the minus st. And when I differentiate it, the derivative of this would have negative s. So to get rid of that negative s, so the derivative is e to the minus st, you have to put a minus s in the denominator. And now I'll want to evaluate that between 0 and r. And what do I get? Well, it is at the upper limit. So it's e to the minus s times r minus, at the lower limit, it's t is equal to 0. So whatever s is, it's 1. And that's divided by this constant out front, negative s. So the answer is, it is equal to the limit of, as r goes to infinity, of e to the negative sr minus 1 divided by minus s. Now what's that? Well, as r goes to infinity, e to the minus, like minus 2r or minus 5r goes to 0. And the answer is minus 1 over minus s. So that's 1 over s. And so that's our answer. Let's put it up here. It's 1 over s. Except it isn't. I made a mistake. Well, not a mistake, a little oversight. What's the oversight? This is okay. This is okay. This is okay. This is not okay. This is okay, but that's not okay. What's wrong? You know, I did sleight of verbal hand. Maybe some of you picked it up and were too embarrassed to correct me. But, you know, I said like e to the minus 2r obviously goes to 0, and e to the minus 5r goes to 0. How about e to the minus 3r? Does that go to 0? No, that's e to the 3r, which goes to infinity. The only time this goes to 0 is if s is a positive number. Minus s looks like a negative number, but it's not if s is equal to minus 2. So this is only true if s is positive. Because only if s is positive is this exponent really negative and large, and therefore going to infinity, going to 0 as r goes to infinity. So the answer is not 1 over s, it is 1 over s, s must positive.